Any questions on the practice exam? No? All right, so let us continue our previous discussion on the thermal cooling. All right, last time we were considering an object which is a glass of water, right? And the temperature of this glass is T. And the temperature of the surrounding is Q0. So we say that according to the Newton law, right? Newton. The change of the temperature of this glass of water is proportional to the difference between the temperature of the glass of water and Q0. So what we have last time is dt over dt is minus k T minus T, Q0. All right? So the change of the temperature inside this glass is dt over dt, and this is proportional to the difference between the temperature of the glass and the surroundings. So this is proportional, meaning that you have a constant k here. All right? So last time we said that this is first order differential equation, which is linear, is equal to k q0. Right? So this is first order. This is linear. This is constant coefficient. And this is non-homogeneous. So last time we said that this is a first order differential equation because we have only one derivative in the temperature. We have only dt over dt. All right? We have, this is linear because you multiply t with a constant, with a quantity k. So this is linear. This k is a constant, so this is a constant coefficient equation. And k q0 is not 0, so this is inhomogeneous or non-homogeneous, right? So what is that? How can we solve this equation? Yes?
We could use the integrated factor method.
Yes. Can you sign back to the paper, please? So we can use integrating factor, right? So what is the integrating factor in this case? Yes?
E to the kt.
Yes. Can you sign at the back of the paper, please? So in this case, we have what? We have dt over dt plus kt, right? So this is the coefficient that we want to pay attention to. So k is the coefficient of t. So you integrate, and you get kt. So the integrating factor is e to the kt. All right? To solve first order differential equation, what you do is that you look into the coefficient of k, of the t. You take the antiderivative. In this case, this is kt, and you take the exponential, right? Now you multiply both sides with this integrating factor. So you have e to the kt, dt over dt plus kt, and this is equal to k q0 e to the kt. All right? So yeah, you have what? E to the kt times t prime plus e to the kt times k times t is equal to k q0 e to the kt. All right? Now, what can I say about k times e to the kt? Yes?
It's the derivative of e to the kt.
Yes, can you say at the back of the paper, please? So this is the derivative of e to the kt. All right? Now you have e to the kt times t prime plus e to the kt prime times t, and this is equal to k q0 e to the kt. All right? Good. Now what can I say about the right hand side? Yes? Yes, can you sign at the back of the paper, please? So this, you can use the product rule. So e to the kt times t prime is k q0 e to the kt. All right? Now what should we do next? Yes? Yes, can you sign the back of the paper, please? Now you're gonna integrate both sides, all right? So you have e to the kt times tt minus e to the k times 0, which is 1, minus, k times 0 times t, 0, and this is k e to the kt. So let me write this one, right? So plus a constant c, right? All right, so now you integrate both sides. On the left-hand side, you have e to the kt times t. On the right-hand side, you have the antiderivative, this guy, plus a constant c, right? What is the antiderivative of this function? Yes?
E to the kt times q.
Yes. Can you sign the back of the paper, please? So I'm going to take the antiderivative of this function. I have q0 times e to the kt plus c. All right? Questions? So I explain again. So in this kind of application, we have what? We have an object, and the temperature of this object is changing. And the change of the temperature of this object is proportional to the difference between the temperature of this object and the surroundings, right? So which means that you have dt over dt is minus k times the difference between t and q0. You have a first order differential equation. In order to solve this, you're going to use the integrating factor method, all right? So to find the integrating factor method, the method is always to look at the coefficient of t. You integrate that. In this case, you get kt, and you take exponential of kt. You multiply both sides with this integrating factor. At the end of the day, you're going to get a derivative on the left-hand side and some function on the right-hand side. All right? Now, you integrate, and on the right-hand side, you're going to get q0 e to the kt plus c. So how do I find t? Yes?
You could divide both sides of the equation by e to the kt.
Yes. Can you sign at the back of the paper, please? So you have tt0 is q0 e to the kt plus c divided by e to the kt. So this gives me q0 plus c e to the power minus kt. Right? So this is basically the solution of this equation. Questions? Screen? Yes?
Since C can be anything, why do you include e to the negative kt?
So when you divide q e to the kt plus c over e to the kt, right? The first thing, the first quantity is q e to the kt over e to the kt. That cancel, right? So the second one is c over e to the kt, which is equivalent with this guy.
Right, but C could be anything. Like
C
C
could
could
be-
just include the value of e to the negative kt. So why do you write it?
No, c is not included in e to the negative kt. C is a constant, right? So you put 2, 3, 4, 5, and k is a parameter that is given in advance. So this is not inside e to the minus kt. Yes? Any other questions? Right? So this is basically the solution of the equation. Now suppose that initially the solution is T0, the temperature, initial temperature is T0. All right? Can we find C in terms of this initial condition? Find C. Now suppose I tell you that the initial temperature of this glass of water is T0. So can you compute C? Yes?
Just when t equals 0, so q0, so c is t0 minus q0.
Yes. Can you sign at the back of the paper, please? So suppose that at the beginning, the temperature of this glass of water is T0. You're gonna replace T0 into this formula, right? With T0. So you have T0 is T of the initial time, which is T of 0. So you're gonna get Q plus C e to power minus K times 0. And this is Q0 plus C. All right, so which means that C is T0 minus Q0. You want to replace it here, so you have T is Q0 plus T0 minus Q0 e to the power minus KT. All right, I explain again. Suppose that initially the temperature of this glass of water is T0. Then you can determine the value of this constant C. You're gonna replace T to be 0 into this equation. So you have T0 is T of T0, and this is Q0 plus C e to power minus K times 0. So this is Q0 plus C. So C will be T0 minus Q0. You're gonna replace it here, and you get this temperature. Questions? It's good. All right, so let us understand the concept, which is the equilibrium. So equilibrium. All right, so an equilibrium is a special solution of a differential equation, right? So an equilibrium a special solution of a differential equation that is constant in time. Constant in time. Right? So an equilibrium is a special solution of the differential equation, and this solution is constant in time. All right? So the equation that we have before is dt over dt of t is minus k t minus q. All right? So what is the equilibrium solution of this equation? Yes?
It would be the solution that makes the derivative of t equal to 0. So it would be when t is equal to q.
Excellent. Can you sign the back of the paper, please? This is a very excellent answer, right? So this is a time-dependent solution. So t is a function of time, right? in this equation, t is a function of time. But we want to know what is the equilibrium solution of this equation, right? So this is a time-dependent solution. All right. Now suppose that we want to find the equilibrium which is independent of time, right? Which is independent of t. All right. So you want to find a solution which is independent of t, which means that this solution is a if you want to find a solution which is independent of t, which means that this is a constant, right? Can you sign at the back of the paper, please? Which means that t is a constant, right? You want to find a solution which is independent of time, which means that this is a constant. So you just plug this constant into the equation. So plug the constant Te into the equation. So you're going to have d over dt of Te is minus k t minus q0. All right? But this is a constant, right? So this is a constant, meaning that dt of t is 0. This is 0 since t is a constant. All right? So t is a constant, so the derivative in time of t should be 0. So, which means that you have what? You have 0 is minus k t minus q0, meaning that t is q0. All right? So the equilibrium solution is nothing but a constant. And this constant is q0. So I explain again. So from the beginning, from the first example, we try to solve a time-dependent equation, right? So we find the solution t such that t is a function of t and t satisfies this equation. Now we want to find a solution which is independent of time, and this solution is now called the equilibrium. So because this is independent of time, this should be a constant, right? So you plug this constant back into the equation. You have the derivative of this constant is minus kt minus q0. All right, so this is a constant. So this derivative has to be 0, meaning that Te has to be equal to q0, and this is the equilibrium solution. Questions? It's clear? All right, so let us try to understand another example. So example. So this is cool. Example. The temperature in the room of the office is 70, right? A cup of coffee which is 1 to f. and the temperature of the cup of coffee drops from 1 to F to 100 F in 10 minutes. In 10 minutes. So, so what is the constant K? Let's see. So now you right. So the temperature inside this office is 7 TF, and we have a cup of coffee whose temperature is 120 F. Now this temperature is dropping very fast. So in 10 minutes, the temperature drops from 1 to 0 to 100, and we want to compute a constant K. So how do we compute that? Yes.
We don't use the equilibrium equation, do we use T of T equals QO plus C minus KT, but C is T0 minus QO. We can put the numbers that are given.
Right. So we're going to use the formula that we had before, right? Can you sign at the back, please? So the solution that we had before was Q at 0 plus K times T0 minus Q0 times e to the power minus KT. All right, this is what we had before. The solution has this form, right? So T of T is Q of 0 plus K T0 minus Q0 times e to the power minus KT. No, there's no K. In this case, Q0 will be 70. Q0 is 70. T0 is 120. Right? So what is the T that we should choose? Yes?
We should let T be 100 degrees Fahrenheit, and then the little t would be 10 minutes.
Can you send the back of the paper, please? So in this case, we have what? We have T of 10 minutes is 100. All right? So the temperature of the cup after 10 minutes is 100. So I'm going to replace everything here into this equation. So you have T of 10 is Q0 plus T0 minus Q0 e to power K times 10. So I put all of the constant inside. So 100 will be 70 plus 120 minus 70 e to power minus K 10. All right? So here I have what? Here I have 100 minus 7 is 3, and this is 50 e to power minus K 10. So you can find this by you have 3 over 5 is e to power minus K 10. So log of 3 over 5 is minus 10K. So K will be log of 3 over 5 minus 10, and we can compute it. We have 553, 33, F. 0.05. 0.05. All right. I explain again. We're going to use the formula. We're going to put the number 10 here, which is 10 minutes. So T of 10 will be 100. All right. Q0 is 70. T0 will be 120. Q0 will be 70. And here we have e to power minus 10k. Meaning that 30 is 50 e to power minus 10k. I'm going to take the log. I have 3 over 5 is e to power minus 100k. And I take the log, so log of 3 over 5 is minus 100k. So k will be minus log of 3 over 5 over 10, and this gives me 0.08, 5. Right? Questions? It's good? All right, so over the last lectures, what we've learned is integrating factor, separable first order differential equation, and application. We have several applications. We have population dynamics, we have temperature, and we have atomics, right, applications. Now, we're going to move to the next kind of differential equation, which is second order. Any questions? It's clear? And the exam will be on the first order. All right? Second order differential equation. Order differential equation. Now we're going to study second order differential equation, but in a very special case with constant coefficient. Homogeneous, and constant coefficients. All right. The form of a second order differential equation will be like this. You have what? You have a this dx dt squared plus b dx over dt plus cx is 0. All right. So this is the form of second order differential equation with constant coefficient, and this is homogeneous. So we have homogeneous second order differential equation and constant coefficient. Right? So there are two ways of writing it. The first one is like this, and the second one is like this. They are equivalent. Right? So here you have 0. So this is homogeneous. And A, B, C are constant. Constant coefficient. Right? In this equation, the equation is of second order. Right? So here you have second order. So the name for this equation is homogeneous second order differential equation. With constant coefficient. Right? So this is a second order differential equation, homogeneous and constant coefficient. So here this is second order because the highest order of the derivative is second. All of the coefficients are constant. This is why we have a constant coefficient here, and the right hand side is 0. So this is homogeneous, right? Right, so one example for this is example. So you have x second plus x plus prime plus x is 0, or x second plus x prime is 0, or x second is 0, or 2x second plus 3x prime plus minus 5x 0. So all of these equations are homogeneous second order differential equation with constant coefficient, because here you have all of the coefficients in front of x second, x prime, and x, they are constant. Here it is 1, 1, 1. Here it is 1, 1. Here it is 1. And here it is 2, 3, 5. Minus 5. The right hand sides are always 0. So this is why we call it homogeneous equation. Right. So let us try to solve, to understand the method that we solve this kind of equation. The two methods that we've learned from the beginning was separation of variables and integrating factor. So those two methods works only for first order differential equation. For second order differential equation, it won't work. All right. So these are for first order differential equation. Now, in order to solve second order differential equation, we are going to learn a new method, which is the characteristic method. Characteristic method. All right. So this is the third method that we've learned in this class. The first one is separation of variables. The second one is integrating factors. Those are methods for first order differential equation. Now, to study second order differential equation, you need a characteristic method. So what is a characteristic method? All right. So to understand the characteristic method, let us try to find a solution of this equation: ax second plus bx prime plus cx is 0. All right. So this is the equation that we study. We suppose that the solution is of the form. Suppose that we look for a solution. Solutions of the forms xt is equal to e to the rt. All right. Suppose that we look for a special solution. Right, so special. Suppose that we look for a special solution of this form. Xt is e to rt. All right. R is some constant that we don't know. R is some constant. Some constant that we don't know yet. All right. It's clear. I'm looking for a special solution of this equation of the form e to rt. R is constant that we don't know yet. Suppose this is 1, 2, 3. Now I'm gonna plug this solution into the equation, right? Plug this solution into the equation. All right. So we're gonna have a e to the rt second plus b e to the rt prime plus c e to the rt is 0. All right. So we're gonna plug this solution into the equation. We're gonna have a e to the rt plus b e to the rt prime plus c e to rt. Now what is e to rt prime? Yes?
R e to the RT.
Can you sign the back of the paper, please? So you have r e to rt. Now what is e to rt second? I'm gonna take the second dude, yes?
R squared e to the RT.
Can you sign the back of the paper, please? So you're gonna get r squared e to rt. Alright? Meaning that in this equation, we're gonna have a r squared e to rt plus b r e to rt plus c e to rt plus equals 0. What can I say about this equation? Yes?
Could you divide out e to the RT as each term on the left, so you get a r squared plus b r plus c equals 0?
Can you sign the back of the paper, please? So here, you see that there's a common factor, right? So e to rt is the common factor. So we have e to rt, a r squared plus b r plus c 0. So you have a r squared plus b r plus c 0. All right? So, this is very good point, right? You reduce one equation, which is a second order differential equation, into a standard equation, right? All right. So example. Example. And if I consider x second minus x is 0. All right? It's clear? In this case, a will be 1, b will be 0, and c will be minus 1. All right? So if I plug everything into this equation, I'm gonna get a r squared plus br plus c is 0, and this is equivalent with a r squared minus 1 is 0. All right? So what are the solutions that we need? Right. No, let me ask again. Suppose that I consider a very special form of the equation x second minus x is 0. In this case, a is 0, b is 0, a is 1, b is 0, c is minus 1. All right? The equation that we found here is a r squared plus br plus c, meaning that r squared minus 1 is 0. So what are the solutions of the differential equation in this case? Yes? Excellent. Can you just add the back of the paper, please? So now you have what? You have r squared minus 1 is 0, meaning that r is 1 or minus 1. All right? So xt should be e to the t, or xt should be e to the power minus t. It's good? Right. So let us check. Check. So if xt is e to the t, what is x second? Yes?
It's still e to the t.
Can you send the back note of paper, please? So if x c is t e to the t, which means that x second t is still e to the t, right? So x second t minus x will be e to the t minus e to the t, and this is 0. So basically, this is a solution of the equation. So e to the t is a solution. So let us check the second solution, which is xt is e to the power minus t. What is x second of t? Yes?
Negative e to the negative t?
No. Just take it twice. Can you both stand up back of the paper, please? So the first derivative gives you minus e to, and you take the second derivative, it is e to the power minus t, right? So x, my second minus x is e to power minus t, e to power minus t, and this is 0. So e to power minus t is also a solution. All right? It's clear? So I explain again. This is the general framework for solving second-order differential equation. You look for a special solution of the form e to the rt. You plug it back to this equation. What you get is a r squared plus br plus c. Example. I consider an equation of the form x second minus x is 0. All right? In this case, x is 1, b is 0, c is minus 1. It's good. So I have ar squared, which is the equation that I found over there. So ar squared plus br plus c is 0. Because a is 1, b is 0, c is minus 1, so I have r squared minus 1 is 0, meaning that r is 1 or minus 1. So the solution will be e to rt, or e to the power minus rt, right? So if I replace e to the t back into the equation, I'm going to have e to the t second minus e to the t is 0, so e to the t is one solution, right? If I replace e to the power minus t into the equation, e to the power minus t is also a solution. It's clear? Basically, the method that you solve is to go from the differential equation to this equation, which is not a differential equation. This is a second order equation, but it's not a differential equation. You solve this equation, you find two solutions, and you take the exponential of them times t. Those will be the solution of the differential equation, and this is so-called characteristic method. So this is a characteristic equation. All right. So you transform a second order differential equation into a characteristic equation. All right. Good. Questions? So I explain again the basic idea, right? You have a second order differential equation, ax prime plus bx, ax second plus bx prime plus c, x is 0. You look for a solution of the form exponential of rt. So the point of this is that when you take the derivative of this exponential, you still have exponential, and some constant r will go outside. And because you resolve all of the exponential after each time you take the derivative, when you plug everything back, you still have exponential everywhere, right? You can put the exponential outside and a common factor, and the level is just an equation of r, which is an equation which is not a differential equation. So you solve this equation, and you find back the solution of the equation. All right? Questions? It's good. Method. All right. So method. This is suppose we need to solve ax seconds plus bx prime plus c, x is 0. All right? What you do is you write the characteristic equation. Characteristic equation. All right? So the characteristic equation will have a very similar form with the differential equation. You have ar squared plus br plus c is 0. All right? So the idea is the following. You keep all of the ABC, right? So here you keep A, you keep 8, you keep B, you keep B, you keep C, and this is C. All right? So you keep all of the ABC, and then the second derivative will become a second polynomial. Right? So the second derivative will go here. The first derivative will go here, and then the zero derivative will go here. Right? This is how you write a characteristic equation. I explain again. You have a second order differential equation of form ax second plus bx prime plus cx is 0. To write a characteristic equation, you write ABC, right? The second derivative of x will become r squared. The first derivative will become r to the power 1, right? And the zero derivative will become r to the power 0, which is 1. It's good? Questions? Right. It's okay. Now, a reminder. What is the solution of AX? Suppose that I have this equation. How do I solve this equation? Yes?
Use the quadratic formula. Because it's a quadratic equation. So it looks to be negative b plus or minus the square root of b squared minus 4ac all over 2a.
Right. Can you sign the back of the paper, please? So this is a quadratic equation, right? So the characteristic equation is a quadratic equation. What you do is what you do is you consider the delta, which is b squared minus 4ac. All right. It's good. So the case when delta is positive. Case number 1, delta is positive, we have two solutions. Which is minus b plus r1 will be minus b plus the square root of delta over 2a, and r2 will be minus b minus square root of delta over 2a. All right? It's good. So this is a quadratic equation. What you do is you consider the quantity that I call delta here. Delta will be b to the power minus 4ac. If delta is positive, strictly positive, this equation has two solutions. The first one is r1, which is minus b plus square root of delta divided by 2a. And the second one is minus b minus the square root of delta dividing by 2a. All right? So we have two solutions. For the differential equation. x1t will be e to r1t, and x2t will be e to r2t. Right? So case number 1, if delta is positive, you have two solutions for the quadratic equation. These are the formula of the solutions for the quadratic equations. And the solution for the differential equations will take the form exponential of r1t and exponential of r2t. Questions? Let us try to do some examples so that you understand better how to solve. So example, you have to solve x second minus 3x prime plus 2x is 0. I have a second order differential equation with constant coefficient, and in this case we have a homogeneous equation. X second minus 3x prime plus 2x is 0, right? This is the equation that I want to solve. Solution. What is the I want to, the first step is to write out the characteristic equation. So what is the characteristic? Yes?
R squared minus 3R plus 2R.
Yes, can you stand at the back of the paper, please? So the characteristic equation will be R squared minus 3R plus 2 is 0. All right? The characteristic equation is taking the same form with this one. So you transform this into the power 2. Power 1 will be this one. So the number 3 will here, and the number 1 will be here. Right? So I explain again. Here you have x second minus 3x prime plus 2x is equal to 0. The characteristic equation will be, first you take a constant, which is 1 here, down here, minus 3 here, down here, 2 here, down here. All right? The second derivative will become the second order, the square of r. The first derivative will become the r, and the 0 derivative will become a constant. This is a second order. This is a quadratic form, the quadratic equation, right? So what is the delta? Yes.
Negative 3 squared minus 4 times 1 times 2.
What is it?
It is 1.
Yes. Can you sign at the back of the paper, please? The delta will be minus 3 squared, minus 4 times 2. So this is 9, minus 8, and this is 1. All right? So what are the two solutions? Yes?
E to the 2t and e to the 3 times 2.
2 and 1. Can you stand at the back of the paper, please? So the first solution will be, so I'm going to use this formula, and minus of minus 3 plus the square root of 1 divided by 2. So this gives me 2, all right? And the second one is minus 3 minus square root of 1 dividing by 2, and this is 1. All right? So you use this formula, right? Delta will be 1, so square root delta will be 1. B will be minus 3, so I have minus 3. A will be 1, so here I have dividing by 2. So I compute that and I have two solutions, 1 and 2, right? So the two solutions will be e to the 1t, which is e to the 2t. So the second solution will be e to r2t, and this is e to the t, right? Can you sign at the back of the paper, please? Can you sign? Right, so this is the general method how you solve a second order differential equation with constant coefficient. The idea is that you write out a characteristic equation, you solve this characteristic equation, you find two solutions, and you take an exponential of them times t. Questions? Good? So there's a better way that you can compute the solution of this guy in mind without using those formulas. Did you know how to do it? A shorter way to compute. To compute R1 and R2. Yes?
This factor R squared minus 3R plus 2 equation.
Yes. So, but how do you choose the two factors? Yes.
R minus 1 and R
Minus 1. Yes. Yes. But I mean, yes, because you know that this is R minus 1 and R minus 2. Right. But I mean, without using those formula, how do you know that the two solutions are 1 and 2? Yes?
We're getting two numbers whose sum is negative 3 and product.
Yes. Can you say at the back of the paper, please? So what you do is you find R1 and R2 such that R1 plus R2 is 3, and R1 times R2 is 2. All right, you don't have to solve the equation. You just have to find two numbers such that the sum is minus of minus 3. So this is minus of minus 3, and this is 3. All right, so you just find two numbers whose sums is minus of minus 3, which is 3, and the product will be 2. In this case, this is clear that it's 1 and 2. All right? Another example, for instance, if I want to solve this equation, r squared minus 102 x plus 200 0, for instance. Right. So for instance, if I want to solve this equation, what I do is I find two constant R1 plus R2 is 102, and the product will be 200. All right, so you can do it in mine, and this, the first one is 2, the second one is 100. Right? This is shorter. You don't have to do the delta and then divide things because in this case the numbers are big. Right? So what you do is you just find two numbers such that the sum is minus of the constant here. So R1 plus R2 should be 102, and the product should be 200. So you can see right away that those are 2 and 100. All right? It's clear? Questions? Right. So we finished the first case, which is the case when the delta function is positive. So let me consider another example, so that you know how to do it better. So example number 2, you have what? You have x second minus 4x is equal to 0, plus 4x prime. Solution. All right, so what is the characteristic equation for this equation? Characteristic formula. So what is the characteristic? Yes?
Excuse me, r squared plus 4r equals 0.
Yes. Yes, can you say it back the paper, please? So in this case, we have r squared plus 4r is 0. So what are the two solutions? Yes?
0 and 4.
Yes. No. 0 and...
Positive 2 and negative 4.
Yes, can you say it back of the paper, please? So the two solutions would be 0 and minus 4. Right, so you have r plus 4 is 0. So the first solution is 0. And the second solution is minus 4. And the solution will be what? Yes?
1 and
Can you say at the back of the paper, please? So the first solution will be e to the r1t, which is e to the 0, and this is 1. The second solution will be e to the minus 4t to the r2t, and this is e to the power minus 4t. Now, I have another question, general solution. So I found two solutions, right? But I want to find a more general form of solution. How can I write it? You just combine them, right? So the general solution will be C1 x1t plus C2 x2t. in which C1 and C2 are constant. Right? That's good. And I said that, okay, if I consider a solution of this form, then this will be solutions of the equation. Why is it? So x1 is one solution of this equation, x2 is one solution of this equation. I combine them by putting some constant C1 and C2. And I said that this is the general solution in the sense that, okay, if I put any constant here, this will be a solution. Why is it? X1 is a solution, right? X2 is also a solution. Now I just take a linear combination of x1 and x2, and I get a new solution. How it is possible? Any guess? Right. So let me give you a hint. So x1 is a solution, right? Meaning that you have what? You have x1 second plus 4 x1 prime is 0. All right? So x1 is a solution, meaning that, okay, x1 second plus 4 x1 prime is 0. You can check this because 1 second plus 4 1 prime is 0 plus 4 times 0, and this is 0. Right? So x2 is a solution, meaning that, okay, x2 second plus 4 x2 prime is also 0 because what? Because e to the power minus 4t second plus 4 e to the power minus 4t prime is 16 e to the power minus 4t plus minus 16 e to the power minus 4t is 0. Alright? x1 is the solution, means that x1 prime plus 4x1, x1 second plus 4x1 prime is 0. This is easy because you plug 1 there, and the second derivative of 1 is 0. First derivative of 1 is also 0. x2 is a solution. This means that x2 second plus 4x2 prime is 0. This is also easy to check, right? So you have e to power minus 4t second is 16 e to power minus 4t, and 4e to power minus 4t prime is minus 16 e to power minus 4t. And this is 0, right? So this is the hint. Why do I combine them and I get a solution? Yes?
Do you solve that equation for the general solution, solve for the constants such that that when you take the second derivative of x and plug it back into formula, and the derivative of x and plug it back into formula, you satisfy original formula?
Yes. Can you say the back of this? Right? Because when I plug this back to the original equation, I'm gonna get something like this. So let me check. So I'm gonna consider this solution, right? So what is x second of t? X second of t will be c1 x1t plus c2 x2t. Second, and what is it? C1 and C2 are constant. Say, okay, I don't take C1 and C2. Let us take C1 to be 1 and C2 to be 3. Okay, so in this case, I consider a special case. C1 is 1 and C2 is 3. And I want to compute the second derivative of x. What is it? Yes?
So it will be the second derivative of x1t plus 3 times the second derivative of x.
Can you sign the back of the paper, please? So this will be x1 prime plus x sub second, right? So you can take the derivative of a sum by taking the sum of all of the derivatives. Right, so now let us compute x prime of t. This gives me x1 plus 3x2 prime. What is it? Yes?
x1 prime plus 3x2 prime.
Excellent. Can you say in the back of the paper, please? x1 prime plus 3x2 prime. Right? So now I want to see this formula again. So I'm gonna sum x1, x2 second plus 4x prime. What is it? Yes?
x1 second derivative plus 3x t is second derivative plus x1 the first derivative plus 3x second.
Yes. Can you say the back of the paper, please? So I'm gonna multiply. I'm gonna take the sum of this and 4 times this guy, right? So this is x1 second plus 3x2 second plus 4 times x1 prime plus 3 plus 12x2 prime. Basically, I add on 4 times 3x2 prime. All right? I'm gonna get the first expression that I have here, and I'm gonna take the sum of this guy plus 4 times this guy, right? And what is it? What is the value of this? Why?
0. Because both of them are 0.
Right. Can you say the back of the paper, please? So now for this one, I'm gonna group this guy and this guy. Right, so this is x1 second plus 4x1 prime plus 3 times x2 second plus 4 times x2 prime, and this is 0. 0. So this is 0, meaning that x is also a solution. Alright? I explain again. I have x1, and x1 is a solution of the equation. I have x2, and x2 is also a solution of the equation. Now I take a linear combination of the two equations. In this case, 2 solutions. In this case, I have C1 to be 1 and C2 to be 3. All right? I'm going to prove that this linear combination is also a solution of the equation. How do I prove that? I'm going to take the second derivative, which is nothing but x1 second plus 3x2 prime. Right? Because it's linear combination, you can just take the derivative of each guy inside the sum. It is also similar for x second, x prime. So x prime will be x1 prime plus 3x2 prime. So x second plus 4x prime will be, you just take the sum of everything, so you have x1 second plus 3x2 prime plus 4 times x1 second plus 4 times 3x2 prime. All right, so you combine all of the x2 and all of the x1. So this is the x2, and this is the x1. All right, so they are all 0 because of this, because they are solution of the equation, which means that when you combine them, x second plus 4x prime is also 0, which means that this is a solution. So you have x second plus 4x prime is also 0, so x is a solution. Right? Now, in this case, I consider a very special case in which here I have x1, c1 is 1, but c2 is 3. But if you consider a general case, then this is the same. Here you have c1 and c2. Suppose that you consider the general case. Here you have c1 is times x1 plus c2 times x2. Everything happened the same way. So here I have c1 and c2. All right. Here I have c1 and c2. Here I have c1 and c2. Here I have c1 and c2. This is c1 and this is c2. All right. So here I have c1 and this is c2. And this is still 0. Expand again. Now, in the previous explanation, I took c1 to be 1 and c2 to be 3. But if you take a general case, in which C1 and C2, they're both arbitrary. All right? So the second derivative of x becomes C1 x1 second plus C2 x2 second. The first derivative of x will become C1 x1 prime plus C2 x2 prime. Right? Now you take x second plus 4x prime. Then this is what you get. You group all of the x1 and all of x2. You see that the C1 and C2, they're outside. They don't have any special effect on the equation. So this is still 0 and this is still 0. So the sum is still 0, which means that x is a solution. So meaning that if you have two solutions, you take any linear combination of this type, of the two equations, of the two solutions, then you will get a solution of the equation, right? And the reason that I can do this is what? The reason is, yes?
Both of the halves, you can call it, are equal to 0.
So the reason is that this equation is linear, right? Right. So because this is linear, you can take, for instance here, this is linear, so you can take the derivative and you throw away all of the constant, and at the end you have a constant outside. But if this is not linear and this is not constant coefficient, you will have a derivative everywhere, and this is not going to work, right? So basically, for any linear equation, if you find two solutions, you combine them, you get a new solution. Questions? It's good. Right. So we finished the first case. So to summarize, for the first case, case number one. Case number one. Oh. So this is the equation that I want to solve. Must be x prime plus cx is equal to 0. Case number one, the characteristic equation. Characteristic will be a r squared plus br plus c is 0. Case number one, delta is b squared minus 4a strictly greater than 0. So you have two solutions, minus b plus square root delta over 2a and minus b minus square root delta over 2a. Alright, so you find two solutions. It's e to r1t and x2t is e to r2t. So you can have a general solution, which is xt is a linear combination of c1 x1 plus x2t. Right? So the first case, the delta quantity is strictly positive. In this case, you have two solutions, r1 and r2. So r1 will be minus b plus square root delta over 2. R2 will be minus b minus square root delta over 2. You have two solutions, which is e to the power r1t and e to the power r2t. Right? Now, as we explained here, you can combine all of the solutions using those constants, and they are also solutions of the equation. So this is basically the general solution that we have. Case number 2, delta is negative. When delta is negative, r1 and r2, what happened to the two solutions, r1 and r2? Yes?
They become imaginary.
Yes. Do you remember the formula?
There's something like the I squared equals -1 and that type of stuff. And then I is equal to the square root of -1. Right.
Can you say at the back of the paper, please? Right, so let us try to go to the next case when delta is negative. So anyone remember a more precise formula for R1 and R2 in the case when delta is negative? So I want delta. So suppose that in this case the delta is negative. I want to find R1 and R2. And so we know that like what you said, we have imaginary. Where is it in this formula?
Where is it?
Yes, where is it? I mean, in the formula here, this is the case when delta is positive, right? But when delta is negative, you have an imaginary guy in this business, right? In this formula, where are they? Yes?
Well, we have this root of delta.
Yes. Can you say at the back of the paper, please? Someone can tell me clearer. Yes?
Well, you would take the I out from under the square root. If that was the same.
Can you say at the back of the paper, please? All right. This is a good answer. In that case, because delta is negative, right? So what is the square root of delta?
Times the square root.
Yes? Yes?
I times the square root of delta?
Delta is negative. Yes?
I times the square root of negative delta.
Yes, can you say at the back of the paper, please? So this will be I times square root of negative delta. Right? So you just have to change this formula a little bit. So R1 will be minus B plus I square root minus delta over 2A, and R2 will be minus B minus I square root minus delta over 2A. So what is the I? The I is the number. So let me remind you. The imaginary number, recall. So the imaginary number I is a number whose square is minus 1, right? I square will be minus 1, right? So now if you want to take the square root of minus 3, say square root minus 4, all right? So this square root of minus 4 will be what? Will be the square root of I square of minus 1 times 4, right? The square root of minus 1 times 4 will be square root of I square times 2 square, right? 4 will be 2 square. So square root of minus 4 will be minus 1 times 4. Minus 1 is I square. So square root of I square times 2 will be 2I. Good. So basically, if you want to take a square root of delta, which is negative, you're going to have to multiply minus 1 to minus delta, right? And delta is positive. Right. So this gives me I square, the square root of minus delta square, and this gives me I times the square root minus delta. In this case, delta is negative, right? So let me explain again. The imaginary number is a number whose square is minus 1. So the idea of this guy is to take the square root of all of the negative number, right? So now suppose that I want to take the square root of minus 4. I want to write minus 4 as minus 1 times 4. Minus 1 I can write it like I square. 4 will be 2 square, right? So the square root of this guy will be 2I. Now I want to take the square root of this delta. In this case, delta is negative, right? I'm going to write delta as minus 1 times minus delta. So delta is negative, so minus delta will be positive. So this is quite normal that I can take the square root of minus delta, right? So minus 1 will be I square, minus delta will be minus delta square. So when I take the square root, I have I times square root minus delta, right? So this formula can be changed a little bit. So I have R1 will be minus B times I square root minus delta over 2A, and R2 will be minus B minus I square root delta over 2A, right? Now, I want to know the two solutions. What are they? Right, in this case, I changed R1 and R2 a little bit so that I can have the imaginary number. Right? But I still want to know x1 and x2. Yes?
Wouldn't x1 of t still just be e to the r1 t?
Yes, it's going to be the same. It's going to be the same. Right? Can you sign at the back of the paper, please? Okay, so we have no more time. So see you on Thursday, and Thursday is the midterm.